So this is the notes over simplifying square roots. You can simplify other things other than square roots. You can do cubic roots, you can do fourth roots, etc. We're not covering that here because primarily in geometry we tend to deal with things that are squared. If you think about the Pythagorean Theorem, for example, a squared plus b squared equals c squared. And there come times when using that equation, among others, that we deal with having to find the square root of something. In those cases, we like to have our answer in simplest form. Much like with fractions, where you expect it to be reduced, simplifying radicals is the same type of concept. What we're covering here is not something that I'm going to test you on directly. Rather, I'm going to include that as part of whenever we do the distance formula, or when we do the Pythagorean theorem, or anything else that requires something squared, where we end up taking a square root. I expect you to be able to simplify those correctly. So we're covering this as a skill that is going to be useful in other things, not just by itself. Okay, so this funny looking thing that we typically call a square root is actually called a radical. It is only a square root when it's written as it is here. There will be other times that you will see a radical with something like this drawn in, where maybe we see a little 3 or a tiny 4 or some other little number written in that little nook. That's what we call an index. When that index is written there, like a 3 or a 4, then we have other roots that we call them. Like, for example, with the 3, we refer to that as a cubic root. If I'd see a little 4 there, then I'd call it a fourth root. But when those numbers are not present, when it's just left the way it is here without that little number, then we refer to it as a square root. But overall, all of them are called radicals. So a square root, remember, is trying to determine what number times itself produces the number that's under that square root symbol. What value, when multiplied by itself, in this case, would give me 40. Now, hopefully we all know there is no whole number that when you multiply it by itself, you get 40. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. Notice I just went straight over 40. So there is no whole number that when multiplied by itself produces 40. That 40, by the way, is what we refer to as a radicand. Some radicands have nice whole number square root values. The square root of 36 is 6. The square root of 49 is 7. The square root of 40 is somewhere between 6 and 7. What we're looking at today is keeping our answers as numbers that don't involve long, ugly decimals. I want something that involves whole numbers. I want something that involves a very short answer. Now, sometimes that means it will be just a whole number answer. Like if the problem says the square root of 36, then you'll just write 6. If it says what is the square root of 100, you would write 10. But there are other times, like this one, where we don't get that whole number value, and we try to find a nice way to put it rather than writing 6 point blah, 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 whatever those decimal places are. And if you wanted to find those on a calculator, it'd be very easy. Type square root 40, enter. And it'll tell you all those ugly decimal places. We don't want those right now. We want exact answers, not rounded answers. So it is useful in determining square roots or simplifying square roots. It is useful to note which numbers have nice whole number square root values. Which radicands have a whole number square root. And those are what we refer to as perfect squares or square numbers. Those perfect squares are numbers that are created by taking some other number times itself. For example, 1 times 1 is 1. And 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16, and so on. Each of these numbers has a nice, pretty, used in my terms, has a whole number square root. The square root of 81 is 9, and the square root of 100 is 10, and the square root of 121 is 11, and the list goes on and on. I would advise in this class that you know the first 15 values. So here I've listed the numbers 1 times 1, 2 times 2, 3 times 3, all the way up to 14 times 14 and 15 times 15. But the list does go on, 16 times 16, 17 times 17, and so forth. This list is not complete. It just keeps going. But they all have this lovely thing in common that when I take their square root, I get a whole number. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. And those become very useful when we're trying to simplify a square root. So what does it mean to simplify a square root? It means to rewrite that square root. Rewrite the radical. In the form a root b. Well, that doesn't make much sense, does it? What are a and b? How am I supposed to know that? A and b are, in terms of what we are doing in this class, whole numbers. They can be other values. There can be fractions that are in there as well. But we prefer for a and b to be whole numbers. But the most important part is that b is not divisible. By a perfect square. So I have to have a value in that radical that is not divisible by 4, and it is not divisible by 9, and it is not divisible by 16. It can only be divisible by 1. I want a b value that any time I divide it by one of those numbers on that long string that I just wrote up above, that the only number on that list that will evenly divide b is 1. So the question becomes, how do we get from this square root that we've been given, as in number 1, the square root of 200, how do we get that simplified? You want to look at that list of perfect squares, 1, 4, 9, etc. Look at that list and find the largest number on that list that will evenly divide the radicand you're given. So on number 1, I want to look at this list of numbers and I want to find the biggest number on that list. And remember which list I'm talking about, this one right here. I want to find the largest number on that that will evenly divide into 200. Hopefully we realize that that's 100. Because 100 times 2 is 200. So I'm going to split this radical apart into 2 parts. And I want you to realize that that is still multiplication. The square root of 100 times the square root of 2 is the same as the square root of 200. Now when I do that, I always write the perfect square first. The square root of 100 is written before the square root of 2. And that's not something that you have to do, but it's a very good habit to get into because it allows your simplified answer to already be in the correct position once you get it simplified. Now, if you find the largest value possible from that list, you need to check, is this other value, this one here, is it divisible by anything on that list other than 1? Is 2 divisible by 4? Nope. Is 2 divisible by 9? No. Is 2 divisible by 16? No. And the list could go on and on and on. But I won't find any value that evenly divides into 2 besides 1, which tells me I found the largest value. Well, what if I had split it differently? Maybe that comes to your mind. What if I thought it's divisible by 25? What if I had split it, instead of as 100 times 2, what if I split it into 25 times 8? That still works. 25 times 8 is still 200. The problem is this is still divisible, that 8 is still divisible by one of our perfect squares. It's divisible by 4. You didn't find the largest one. So if that happens, if you end up with a value of b that is still divisible by one of those perfect squares, that means you need to look a little higher. You haven't found it yet. And that's where you would find this 102. So once you've determined the highest value that you possibly can find that evenly divides that radicand, then you want to simplify each of them. One of them should simplify, the other one shouldn't. For example, the square root of 100 is 10. When it is a square root and it has a perfect square as its radicand, it becomes a whole number. The square root of 2 is a decimal. I don't want to see decimals, so I leave it as a square root of 2. That becomes the simplified answer. It's in the form a square root b, where a is 10 and b is 2. A square root b. So we look at number 2, and we'll do the same thing. I want to find the largest value on our list of perfect squares that evenly divides 68. So we split that one apart. Let's see. 68. Now I know that 68 is not going to be divisible by anything greater than 68. So what I would start with, if you don't recognize one automatically, start with the number that's closest to 68 and start working your way backwards down the list. So 68 divided by 64. That gives me a decimal. And then I try 68 divided by 49, which is also a decimal. And 68 divided by 36, still a decimal. And I keep going until I find one that works. And the first one you will find in this case, 68 divided by 4. And when you take 68 divided by 4, we write the 4 down first. Remember, it is still a square root. We haven't done anything to it yet. And I want to take 68 divided by 4, and that's where we're going to get 117. If you need to, you can do it with a calculator. You can do it by hand. That's why you were taught those things when you were younger. So once we have it split, double check, is the 17, is this divisible by anything else on that list besides 1? No. 17 is a prime number. It's only divisible by itself and 1. Okay, now we simplify. The square root of 4, its perfect square, becomes a whole number 2. And the square root of 17 stays as is. Now there are six problems on this page, 4 others. I want you to pause the video at this point and try them on your own. Whenever you have them done, start the video back up and check yourself. So the square root of 120 is divisible by 4, and that is the highest value that will evenly divide it. Splits into root 4 times root 30. Square root of 4 is a whole number 2, and the square root of 30 doesn't simplify. On 4, you'll find that the only value that evenly divides into 39 off of our list of perfect squares is 1. Now the square root of 1 is 1. Square root of 39 is a decimal, so we leave it as is. Now with your experience in algebra, you should know that when multiplying by a 1, you don't write that coefficient of 1. So in this case, we just simply leave it as a square root of 39. Now what we would say about this particular type of square root is that it does not simplify. Meaning there was no value other than 1 that evenly divided into 39 off of our list of perfect squares. When that happens, don't write the 1 out at the front. Okay. Number 5, the square root of 384. The most common mistake that I see on this one is that people don't choose the largest value possible. In this case, 384 is divisible by 64. And I've forgotten what it is. There it is, 6. 6 times 6, 38. So here it should split into the square root of 64, maybe, and the square root of 6. Square root of 64, whole number 8, and the square root of 6 stays as is. And the last one. 25 evenly divides into 250. Its other factor being 10. Square root of 25 is 5, and the square root of 10 is a decimal, so we leave it as is. And remember, each time you separate that radical into two portions, you have to be certain that one of them is not divisible by a perfect square. If it is, then you haven't found the largest one. Try again. Now, there are other ways other than just finding the largest value. There are other ways to simplify square roots. I am not going to show you those here because I want everybody to kind of have a uniformity to what they're doing. However, if you are at a point where you really just cannot do it this way, then you come find me and I will show you another way to do it that may work better for you. I don't want to show the entire class, but I will show you individually if that's what needs to happen. And that takes care of simplifying square roots. Now, there was a worksheet in class that accompanied this set of notes that you should have done for practice. You need the practice. Everybody does, so make sure you've done that. Tomorrow we'll be looking at, or in coming days, we'll be looking at the distance formula, which is an extension of what we've done before with the Pythagorean Theorem, but it requires you to know how to simplify square roots. So make sure you've got this underfoot, so to speak, that you know how to do it before we get to the distance formula, so you're more likely to be successful with that as well. If you have any questions, you know where to find me.